All right, hello guys, welcome back. And today we're going to hit review just a little bit more with factoring, and then after this we should be on to our first chapter, which is functions. But we're really going to focus on the difference of squares today, which we have already looked at, but I just want to look at it again because I felt like we were a little iffy on it. So, what do you notice when you multiply x plus 7 times x minus 7 in parentheses? Well, we would get x times x is x squared, and then we get times minus 7 would be minus 7x. 7 times x would be plus 7x, and then 7 times negative 7 would be negative 49. And here you're going to have to cancel your minus 7 and your plus 7. You're going to be left with x squared minus 49. So the thing to take note of is here, we kind of had the same thing going on, right? We just had a plus and a minus. So we had the same x, and 7, except 1 is negative. And what will happen every time you have something like that is these middle terms are going to cancel out, and you're going to be left with whatever variable you had squared, and then a perfect square. And 49 is a perfect square. And if you don't know your perfect squares, you should get used to them, right? Your perfect squares are 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared, 10 times 10 is 100, and if we're getting up there, 11 squared is 121, and 12 squared is 144. And so if you see any of these on the right side, like 49 here, when we factor and we're going backwards, right, we'll end up with what's on the left side. So when we see 49, we should think, oh, that's 7 squared, so that'll be x plus 7, x minus 7. And that's our difference of squares, right? A squared minus b squared equals a plus b times a minus b. And just a quick example, x squared minus 16 equals x squared minus, and then 16 is 4 squared, right? So then we're going to do x plus 4, x minus 4. And we can, and that's what I'm talking about. When you see 16 here, you should be able to be like, oh, right away. Or if not, you look at your notes and you see that 4 squared is 16. They're the same thing. And so then you could write this from that. So example 1, x squared minus 49. I know that is the same thing as x squared minus 7 squared. If you don't recognize it right away, it could be helpful to write that, because then you know it's x plus 7 times x minus 7. All right. And then here is a good example because the order matters, right? So this is 25 is 5 squared, and then we have q squared. And now the order matters, right? So when we break it up into our two binomials here, we have to do 5 plus q, 5 minus q, right? So this is the correct answer here. If you wrote it like this, would be wrong for this one because it's not the right order. So not that one. T squared minus 81, this is just more practice. Maybe we could start to think ahead now instead of writing it out. As soon as I see that 81 is a perfect square. 9 squared is 81, so we're going to do t plus 9 and t minus 9. Right? And then x squared minus 1, this one might trip people up, but that's really just x squared minus 1 squared, right? 1 squared is 1. So this is really x plus 1, x minus 1. And then our last one here, g squared plus 4. I thought I'd throw this one in here. This one we cannot factor because notice here we have plus. If we have plus, we can't do it. We need, notice how the rest, minus, 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 minus. And if we go back to our rule, notice our rule only has a minus in it. So since we have a plus there, that is fully factored and we can't do anything with it. So getting on to maybe some tougher ones. So we can recognize this 25 as a perfect square. 5 squared is 25. But now what do we do about having this 4 out front? Well, if you think about it, 4 is also a perfect square, right? 2 squared is 4. And so we could rewrite this like this. This is 2x squared minus 5 squared. Right? So kind of the trick is you can think of the square root of this number as well. Just because it's a coefficient on x doesn't mean anything, because 2x squared, what is 2x squared? That means 2x times 2x. And that's, well, 2 times 2 is 4, and then x times x is x squared, right? It's the same thing. And so now we can recognize this as our a, and that 5 as our b. So then a plus b would be a, which is 2x, plus b, which is 5. And then a minus b, a is 2x. And then minus b, and then b is 5 in this case. So that would be our answer. Same idea, except now we're kind of dealing with this little coefficient in front of an x squared. Same idea, except now also the order matters, right? So this, we know 25 again, that's 5 squared. We should recognize that one right away. Now it gets a little weird, but let's just think about it. 64, that we should recognize that as a perfect square too. That's going to be 8 squared, but we also have that q squared tagged on. So really, it's 8q put together squared. Just like the last one, except now the two terms are kind of flipped. And so now we just follow our difference of squares rule, and it would be 5 plus 8q times 5 minus 8q. And then our last one here, this is x squared. So the difference with this one is now we have a variable on each one, right? But let's just write it out like we would anyways, right? So this is x squared, that's already nice for us. Ooh, and now we have this thing again where we have a coefficient out front, but 9 is also a perfect square. 3 squared is 9. But we need to tag that y onto there too. And so now we just follow that formula. That would be x plus 3y, this whole thing, and x minus 3y. And you would definitely have to get used to doing something like those ones. Now, we're just going to hit review really quick a little bit. So, multiplying these binomials, again, we're going to do that. X times x is x squared, and then I hit the other one. 15 times x is plus 15x. Minus 3 times x is minus 3x. The negatives matter. Negative 3 times 15 is minus 45. And then x squared, and then we have two like terms. 15x minus 3x is going to be positive 12x. And then we still have minus 45. And that is our answer. 3x times 2x is going to be, do the numbers first, 6, and then x times x is x squared. 3x times minus 5 is going to be minus 15x. Negative 1 times 2x is going to be minus 2x. And then minus 1 times minus 5 is going to be positive 5. Right? And now again, we have 6x squared, but we can combine negative 15x minus 2x. That'll be minus 17x plus 5. And that's our answer for that one. And then here's factoring these, which we should get a little used to doing, right? So now we're going the other way. And I'm just going to set my thing up right away with an x on each side, because I know I'm going to have to get x squared. And then this negative tells me that this negative here tells me that one of these needs to be positive and one needs to be negative. And now I just need to find the numbers. What numbers multiply to negative 28 and add to positive 3, that middle number there? So I'm just going to start listing the multiples of 28, because sometimes it's hard to think. So 1 and 28, I don't think that's going to work. 2 and 14, that's not going to work. Do we have 3? No. 4 and 6 isn't going to work. Or it's not 4 and 6, it's 4 and 7, right? 4 and 7. And I think those will work if we make the 4 negative, right? Because we need this addition to be a positive 3, so we're going to need the bigger number 7 to be positive. There we go. And now same thing here. I'm just going to get it ready. And this positive tells me that either both of these need to be positive or both of them need to be negative. But then this negative tells me that they should both be negative, right? Because when I add them up, I'm going to have to get a negative number. And there's no way I can get a negative number by adding 2 positives. So again, let's just make our x so it's easier for us. We need to multiply to 22, and we need to add to negative 13. And I can kind of see right away we're going to need a negative 11 and a negative 2. Both of those, negative 11 times negative 2 multiplies to positive 22, and they add a negative 13, so negative 11 and negative 2. And again, if you need to check those, all you do is multiply this back out. And if you get what you started with, then you got it. But that is going to wrap up our difference of squares factoring, mixed in with a little bit of review.